start a new course. The name of the course will be Digital Electronics. This course will have a separate playlist in my YouTube on my YouTube channel. So anybody wants to access to this one, so they can have it through that playlist channel, from the channel playlist. And this, since the name is saying digital electronics, just to have a general idea, digital electronics are something, any device that have electronics in it, and that device might have both digital and analog, but we are more focused in this course to discover what digital electronics are in a circuit. So let's move on and not waste more time and talk about what these things are. So by the end of this video lecture, you should know the following. What a signal is, any kind of signal, what a signal, just we have to define a signal. What does that mean to have a signal? And then when we define a signal, we will have to go like what a digital signal is, and then what an analog signal is. These things will be uh, discovered in a great extent in the upcoming time right now in this video. So please stick around. I put this signal there, the traffic light signal, because as we see, it is a signal. It tells you what to do. Like green, red, and yellow lights means some sort of meaning to you, to us as a drivers. So for that, when I put on this slide, so we should get an idea what a signal's definition is. Then putting this signal there, is that a digital signal on there or analog signal? And then if you find out what a digital and analog signal is from this diagram or from this graph, it will probably give you a good idea what a digital and analog signal looks like. Then we will say like, okay, it's in a previous day, now we have a YouTube and all these Pandora music stuff. Before we had a CD desk, a digital, uh, sorry, I did answer that. A CD desk, we could hear music on it, and we could watch movies, and like a CD, a compact disc. Is that digital or analog? But I did answer that was a digital. Is a VCR digital or analog? We will go and talk about these things in the rest of the video. So by the end of the video lecture, when you go back to this second slide, and you will have to answer, you will be able to answer these all questions. So stick around for the next session. Oh, sorry. Yeah. Then the last topic here is that like what is noise? When we talk about noise, noise is something that happens and you don't want it. For instance, like your neighbor's kid is yelling or just jumping around the floor. That is one sort of noise. Playing, and when you stop by a traffic light and you see somebody pull their windows down and they make their music so high so you can't hear or you can't focus something, that is another kind of noise. But here in this course we'll be talking about a noise in terms of digital electronics. We will discover that and we will define that. So hopefully you learn something from this first video of the digital electronics. So moving on.
Digital electronics. Um, we asked in the previous slide what a signal was. So let's define signal. A signal is an electrical impulse used to carry data from one device to another device. If that device is a human being, from a human to human, it's a signal. For example, I'm just waving to a person. I said like, hey, that means hi. So that the second person will wave back. So it'll give me the feedback to me like, hey, I got your message. So that's back to you. Is it hi or any conversation or say, hey, how are you? So that is a signal or a traffic signal. If you see a red signal, the human beings are trained to stop at a red signal and the green, then go and pass that signal. And a yellow signal, usually on the traffic signal, yield or slow down until you are safe to stop. So this is how the definition of a signal is. Now electronics are divided in two categories here. It has analog electronics and digital electronics. The analog electronic was previously was vastly used in the large technology in the earlier times. Since today the world is getting through the digitalization, so most of the circuits or circuitry are becoming digitals. So these are there will be still a lot of circuitry that will use the analogs and the digital both together. For example, our modern cars, they use the analog circuitry and digital circuitry both together. Okay, moving on. So how do we know, or how can one know that a circuit is a digital or analog? So just to be very clear here, if you are looking for a digital circuit here, so we have to answer some of these questions. If any of these questions is yes, then we will say yes, this is a digital circuitry. The question will be following. Well, number one, does the circuit or circuitry has a display that shows the number in picture or videos? That will be example of a TV, laptop, mobile phone. So they have a display. It shows a number, picture, and videos. That modern days phone, TVs, and those has that capacity. Number two, can it store something or has memory? Can it store some data or has memory? Yes. In our modern days, TVs, phone, um, what else? Laptops, iPads, um, these devices store and has a memory, so we can call like, okay, yeah, we said yes, so that is a digital. Number three, can it be programmed? By programmed mean that can it remember what I tell it to do? For example, setting up an alarm. It has a display that has a numbers, and can I program that? My phone, my TV, or for example, my laptop or anything. So if the answer is yes, then yes, it is digital. If the answer is no, then it's not. Now, number four is internet connection. Then that mean, can it be connected to the internet? This is a very modern days, because the internet is not that old. It's been around since probably my age, or a little bit earlier than that. But the very old days, electronics didn't have internet, so we probably said like they were analog, because this is the new question that we added there to discriminate between analog and digital, or to differentiate between these two. The internet connection will be one of the differentiation between analog and digital circuitry. Okay, so these questions will be, to repeat it again, does the circuit has a display that can show picture, numbers, or videos? Number two, question number two will be, can it store something? Can it store a memory? Can it store a data? Number three, can it be programmed? And number four, internet connection. It has any internet connection, or it can be connected to the internet. If any of these question is yes, then it will be digital circuitry. Now the question is, why we are so eager to use digital over analog these days, or why is it becoming so famous? There should be a several reason for that, and there will be. Why we are using it? The first answer, easy to design using IC integrated circuits. We will talk about them, and later on this course. So right now it's those chips that we put it in the modern days technology circuit board. So it's easy to design using ICs. ICs mean integrated circuits. Number two, can store data. They can store data. They have a memory that can store any data. not any data, but some data, or any data, but data. And number 3, it's programmable. You can change the setting, you can program it the way you want it. And number 4, it's accurate and precise. It's since it's a digital, it's more precise than it could be the analog. Number 5 is less affected by unwanted interference, and we call that noise. What is noise? It's unwanted signals or interference in a signal system. That is noise. Number 5 is less affected by unwanted interference, and we call that noise. A noise is, we'll put here, let's give it some space here. Oh, that's not right. Go back. That's better. Let's define noise here. What is noise? Noise, hope I spelled it right. A noise is an unwanted signal which interferes with the original message. Unwanted signal that interferes with the original message. I'm sorry about my spelling. Interferes. Let me clear that out so not to confuse anybody here. A noise is unwanted signal that interferes with the original message. The original message or signal. So that is the definition of a noise. What is noise? A noise is unwanted signal that interfere with the original message or signal. Now there are a couple questions that I ask here. Okay, the volume control of a stereo is an analog signal, and that is why. It says why. Because how do we control our stereo volume there? Some of them have a knob, and this knob will be turning to the right when you try to make your music louder. It'll be louder, and if you turn it left or counterclockwise, it will be light music or slower music. The idea behind that is from the Ohm's law, from the current formula, is V over R. It's directly, since it's they use here, it's a variable resistor here. They're using a variable resistance or potentiometer. We call it pot. That means if my resistance, let's say for example, our stereo has 5 volts. If our resistance at normal is if you set your resistance to 300 ohms, so I, or the current, will become 5 divided by 300 will give me 0.016 ohms, amps. But if my resistance goes lower, for example, I turn the knob all the way to the right, so the rest, let's say resistance is 5 over 5. Now I get 1 amp. 1 amp in terms of music or stereo will be very loud music there, so it can disturb your hearing. And hopefully later on I do talk about the decibels. Will be decibels, which is used for, this will be used for noise, for sound, for hearing, anything we will use this. We will for now I'll leave it right here to this point, but in the future I hope I do cover that course too. If I don't, please forgive me, but I will be trying to cover it. If I don't forget it, we'll talk about decibels, what they are and how do we calculate that. So right now it will be this if this is the case, if our resistance goes low and voltage stays the same, there will be increase in amp, and that will be higher volume. So that means we can control that analogically. We can control it, decrement it by set increase it and decrease it incrementally, and we can decrement it too. It's not like 1 or 0. No, we can go different values because we can set that potentiometer in any place. That's why it's analog, not digital. Now the second question here is high beam automatic lights of a vehicle is a digital signal. Why? Okay, so how these works, I talked about ICs or integrated circuits before. In the modern vehicle, they use these circuits, and they have in a modern vehicle, let's say for example my Cadillac, it does have more than 20 computers or somewhere like that. Each computers or each circuit board or each IC is designed for a specific job. If I'm driving in a dark mode, if I'm driving in a dark countryside and there is no vehicle coming from the front side, so I'm only one driving, if my vehicle detect too much darkness, it will turn on the high beam. If it detects dark and no car, it will turn on high beams. Not beams, but beams. So that means the signal will be 1. But if it sees a car or brightness, now they will turn off the light. It will become 0. The light will go off, which is 0 in terms of digital electronics. And the high beam is what is it? It's a digital signal. So once it sees the darkness, it will turn on the high beam without your input. But if it sees a vehicle coming your way, it has lights on, so it can detect that vehicle. Hey, I got somebody coming in from, so I don't want to blind him. It will turn off the high beam automatically. So that's digital. That's why, because it goes off and on. There doesn't have anything in between. Now it says modern days automobiles brightness of a dashboard is analog signal. Why? Analog signal, we said, like it can varies in terms of times. That means in the modern days the dashboard is analog. Why? Let's say I'm driving somewhere and the sun is facing me and I'm facing sun. It is so disturbing sometimes that you can't see your dashboard. These IC or integrated circuit board are designed, if they see somewhere more lights, it will turn on. So it will adjust. If it sees light, if it sees more bright light coming toward your dashboard or is hitting your sensor or a camera, anything is installed there for the driver's convenience, what will it do? It will adjust the brightness of dashboard. Why do they do it? It's a safety feature. Safety feature, so you can see your tachometer, you can see your speed, you can see your, in the modern days you can see your, like if you're not if you are in your lane, if your fuel gauge is okay, if your heat system is okay, if your battery system is okay. So that dashboard is not dashboard, that tachometer, you can see everything in there. That should be for that. You can see it, and that is analog because it can be adjusted. If it is high light outside, so your light of the dashboard or the tachometer or any display that you can see inside your car, if it is too bright outside, your car will automatically adjust the brightness of your dashboard, so it will go higher, so you cannot get disturbed from the outside lights. You will still see the light inside the dashboard. Or vice versa, if the outside is too dark, your car will adjust the light so it does not the internal lights does not disturb you, so it will dim your dashboard light, so you can because if you see something bright near you, then you cannot see far from you which is darker, so they will have to adjust the light according to your nature, and that's been programmed that way. And yes, it is a combination of digital and analog sensors or digital circuitry in this setting. All right, so we said what is a since we said we give these examples, I hope you get some idea of these from these examples. So what is a digital signal and what is a analog signal? You guys have any idea? If you do, please pause and say it. Digital signal, a signal that has only one value at a given time. Like I said, like the high beam example. If it detects a car, it will turn off. If it doesn't detect a car, if it detects darkness, it will turn on the light. It has only one value at a given time. Or to put it this way, a signal that represents data as a sequence of discrete values. For example, TV, phones, high beam lights, and everything that has a digital circuitry. So a signal that represents data as a sequence of discrete values. So yeah, we said like the example is TV and phone. Now what is a discrete value? So discrete value is a data set or data that has a certain values or take a certain values. It has a certain value or it takes a certain value. For example, the number of people that works in my company, that is a discrete number. The number of people that work in Starbucks, for example, the number of car that I have, the number of car that someone has, that's a discrete number. So that being said, the digital signal is a signal that has only one value at a given time, or it represents the data as a sequence of discrete values. So we said that discrete values are positive integers, because we don't in digital electronic as of now. As of this point of the course, I don't have anything that represents negative binary system, but we will have something like that. I'll talk about that maybe or maybe not in this course, but it'll be higher engineering classes if I do cover them. And see what we define the digital signal there is. Digital signal is a signal that has only one value at a given time, or the signal that represents data as a sequence of discrete values. Hope it's not very complicated. I will go through again. A digital signal is a signal that represents data as a sequence of a discrete value, or it has only one value at a given time, like 1 or 0. So that's it. So that will be like that: on, off, on, off. So it's a one value at a given time. Okay, now moving on. What is analog signal? An analog signal is a signal that uses continuous time to represent data or values. Continuous time, for example, in 0.1 second is different, 0.2 seconds is different, 0.3 seconds is different. So that will be like that. So each time, this is a t. So while the time changes, it keep going back and forth. It just changes its value. So analog signal is a signal that uses continuous time to represent data. So any second it will be changing, like a AC voltage, I would say AC current. We have AC and DC. AC is a sinusoidal, so it changes respect to time because it's sinusoidal. DC is a discrete. It will go that way. It will go have a one value at a given time. So analog signal, to define it again, is a signal that has that use a continuous time to represent a data or value. Okay, let me clean this one, this mess that I made here. Okay, let's move on. Example of analog device or analog circuitry will be a watch, the clock, the wall watch, because it has a different. If it has a, it keep changing. The needle is moving, so it's changing with respect to time. It's changing, and each time it has a different value. Each time it has a different value. For example, this is watch. And then here will be this one at 1 o'clock, at 3 o'clock, 4, 5, 6, and it's keep changing. The clock will. And video cassette recorder, VCR, that is the analog signal too. Because let's say if you play that the VCR video all the way to the film you played or the movie you play all the way to the back. So now that has to be unwind back and bring it back to the beginning to start it over. While as a digital disc or what do you call CD disc is a digital, because you don't have to do that. It's either off or on. You can, and it will store the date. It will store the memory to where did you left it. And VCR does it too when you turn it off, because the VCR is a hard cassette. It does go by the winding of the tape. But CDs, you can start from the beginning. You can forward it relatively quickly, because they're using ones and zeros in terms of a lot of hexadecimal numbers, so you don't have to wait for a long time to play your movie. So that's why the VCR is a analog, and the CD, the voice or the audio tape cassette is a analog too. I hope this is clear. That's what that will be in. The VCR are still around, but that's not that desirable technology to use now, since we have the CD cassettes are becoming obsolete right now. So everything is digitalization. Every music that you want, you have it on your phone, on your computer, or directly to your TV through the internet. So these are becoming very obsolete right now, especially the VCR. CDs are still around the world, they're still using it. There might be some people still use VCRs too, but they're absolutely obsolete in US, in the United States of America, as that was a audio cassette tape recorder. Okay, so that was it for today. In digital circuitry, we use high and lows, as I said, like, high. For example, this a signal is 1 here, 0 here, then 0 right here, 0 here, 1, 1, 0. So we call it like a high. This is the high, and this is low, and that's how we use it in digital electronics. And these 1 and 0 are called in the binary system. These are the binary numbers, and we will talk about that in right before somewhere next weekend. I'll be uploading this course video every week, at least 1 or 2 videos. So we'll talk about the binary number next. So please stick around, and if you want to learn anything, something about the digital electronics, we'll be talking about the binary systems, the binary numbers. If we will go all the way to octal numbers, which is base 8, binary is base 2, hexa is 16, and decimal is base 10. We'll talk about these, and we will, from then on, we will go after that. We will be talking about the logic gates, and probably we will go to TTL also, and IC, integrated circuit board, integrated circuits. To learn more, I would recommend please to subscribe this channel. You'll learn a lot, since I'm not only teaching this course, I'm teaching electricity also, and I'm teaching math. I'll be taking math to a very high level. If you like these videos, please go and hit that subscribe button. Until then, Take care, guys.